Practice with linear slash exponential growth and decay by Olivia and Kasia.
We are doing an exponential growth problem. Here it is. Abby is just about to leave the house and go trick-or-treating when her mom gives her 2 pieces of candy. The next house gave her 4 pieces of candy, and then the next house gave her 8 pieces of candy, and so on.
To solve the problem, we must first create a table. We will start by filling in the x value, the number of houses. 0, 1, 2, 3, and 4. Now we will fill in the pieces of candy. She starts with the 2, then she gets 4, then she gets 8, then she gets 16, and then she gets 32.
Now that we have the table, let's find out the explicit and recursive rules.
Our start value is 2, so that will be our a in the equation. And then we are multiplying our 2 by our common ratio, which is 2, because 2 times 2 is 4, and so on. Now for our recursive rule, which is a now next equation. So next equals now times 2, because 2 is what we're multiplying by. And our start value is 2.
Now it's your turn. Let's read problem number 1. How many pieces of candy can Abby expect from the 10th house?
You should have gotten 2,048.
Now let's do problem number 2. How many houses has she gone to reach 30,000 pieces of candy?
You should have gotten 13 houses. Now let's make a graph. This is what your graph should look like. Now you've finished the exponential growth problem. Now we have a linear growth problem.
Kim owns a tutoring business that tutors in science, math, and English. The start price for tutoring is $25, and for each hour the price goes up by $15.
Now for our table. The original price of tutoring is $25. The first hour is $40. The second hour is $55. The third hour is $70. The fourth hour is $85. The fifth hour is $100. And the sixth hour is $115.
Now for our equations. Our recursive equation would be next equals now plus 15, and we started at 25. Our explicit equation would be y equals 15x plus 25. Now for some extra practice. How many hours of tutoring would you have to do to pay $160? You should have gotten 9 hours. Look at the work below to see if you got the answer wrong. Here's another practice problem. How much will you pay for 12 hours of tutoring? You should have gotten $205. Here's the work below. Here's the graph for the table that we did on the side.
Now for an exponential decay problem. Stacy bought the first iPhone in 2007 for $100. The phone company said it depreciates 5% every year. Here's the table for the problem. At 0 years, the phone costed $100. After 1 year, it costed $95. After 2 years, it costed $90.25.
On the third year, it cost $85.74. On the fourth year, it cost $81.45. And on the fifth year, it cost $77.38.
The equations for the problem are, for the recursive, next equals now times 0.95 with a start at 100. And the explicit equation is y equals 100 times 0.95 to the x power.
Here's the first practice problem. How much will the phone be worth after 9 years? You should have gotten $63.03. For the work is shown below. Our second practice problem is, when will the phone reach a value less than $60? You should have gotten year 10. The work you can do is plug into your calculator into y equals and press second graph, and then you'll get year 10's value.
Here's the graph for this problem that is based on the table.
This is a linear decay problem. Renly just bought a car that was worth $5,000. Every year, the value of the car goes down $252.
Here's the table. At year number 0, the cost was $5,000. That's the initial price. At year 1, the cost was $4,748. At year 2, the cost was $4,496. At year 3, the cost was $4,244. At year 4, the cost was $3,992. Now for the equations.
Our recursive equation is next equals now minus 252, and we started at 5,000. Our explicit rule is y equals negative 252x plus 5,000. This is our first practice problem. How many years will it take for the car to only be worth $3,236? You should have gotten 7 years. The work is shown below.
After 11 years, how much will the car be worth? The answer is $2,228. The work for this problem is shown below. Here's the graph for this problem overall.